So in the Unit 4 extra credit, this is going to be talking about symmetry. It's a topic that we talked about before, just making it an extra credit topic for this OST review. So take a look at example 1. It says rhombus PQRS is shown on the coordinate plane. Points M and N are midpoints of their respective sides. Select all the transformations that map the rhombus onto itself. Select all the transformations that will map the rhombus onto itself. Sorry, I got repetitive. Let's try that. Okay. So what we need to do is go through and figure out our lines of reflection and our angles of rotation. So whenever we're reflecting over a line, so I like to do my lines of reflection first. Okay. That's pretty much saying a line of symmetry. So it's asking, is PR, so P to R, a line of symmetry for that rhombus? In other words, if we fold that rhombus over that line, will everything map up? And the answer is yes. So one big important thing to remember, if we're dealing with a rhombus, their diagonals are always a line of symmetry or a line of reflection. Every time. It's because what's special about a rhombus is all the sides are the same, so the sides will map up. Also, their opposite angles are the same, so the angles will map up as well. The sides and angles will map up when you fold along that line, so it makes it a line of symmetry. If we take a look at the next one, a reflection across MN. It's really tempting to say this is a line of symmetry, but it's not. The reason is the sides will map up when we fold along that line, but the angles don't. This angle is not the same. P and Q are not the same. P is bigger than Q. So when we fold, it's not going to map up. Therefore, it's not a line of symmetry. And then if we take a look at the next one, QS. QS is a diagonal of that rhombus, so yes, it's going to be a line of symmetry. Diagonals of a rhombus will always be the line of symmetry every time. So if you're drawing a diagonal, it's going to be a line of symmetry. For the angles of rotation, so what this is saying is, can we rotate this rhombus about its center, and it will map up onto itself. So the first one's saying 90 degrees. If we rotate it 90 degrees, that obviously does not work. Okay, so that can't be an answer. Well, let's see, what about 180? And yes, 180 does work. Okay, so 180 is an answer, 90 degrees is not. Here's the thing. You can't do that on your screen. You don't have a smartboard when you're taking your test. So my suggestion would be to copy the rhombus on your scratch paper and turn your paper 90 degrees. So 90 degrees, you turn it one time. And it's clearly not going to look like, it's going to look like something like this when you turn it on your paper. And it didn't match the original. So then turn it another 90 degrees, and it ends up looking somewhat similar to what is originally there. So that's telling you that 180 degree clockwise rotation works. And clockwise and counterclockwise, I guess 90 degrees clockwise would have been from the original that way. But either way, it just doesn't end up working out. Okay? But 180 degrees does. So a rule of thumb with the symmetry of a rhombus: 180 degree rotation, clockwise or counterclockwise, around the center of the rhombus always is the angle of rotation. Reflections over the diagonals are always lines of reflection. Okay, those three will always be transformations that will map that figure onto itself. Okay. So again, whenever we're talking about mapping a figure onto itself, we're talking about symmetry. If we take a look at example 2, it says parallelogram ABCD is shown. Point E is the midpoint of the segment AB. Point F is the midpoint of the segment CD. Which transformation carries the parallelogram onto itself? Meaning symmetry. Whenever we're dealing with just a parallelogram, you have to remember parallelograms, just a regular old parallelogram, has absolutely no lines of reflection. They have no lines of symmetry. Okay? What they do have is rotational symmetry, meaning we can rotate it exactly 180 degrees and it will map up onto itself. That is a parallelogram's only symmetry, is rotational symmetry of 180 degrees. We'll Well, there's two answers that are talking about rotational symmetry of 180 degrees. You have to pay attention. The answer is D, is because we have to rotate the shape about its center. Because when we rotate it about its center, it's staying exactly where it's at. It's just kind of turning in that area. Okay? When we're rotating it about the origin, it's jumping quadrants. So it would end up landing somewhere in quadrant 2 if we did it about the origin. So that's not going to map it onto itself. It's going to move it to a totally different quadrant. So it has to be D. So we have to map it around the center. Now, if the figure is centered at the origin, then yes, rotating it about the origin will work, but it's not. So it has to be around the center of the figure. Pay close attention to that. They like to ask those questions to trick you. If we take a look at the last example, it says a square is rotated about its center. Select all the angles of rotation that will map the square onto itself. So we take a look at a square. It might be helpful to draw it. We first have to figure out what is it, square's angle of rotation. And to figure out the angle of rotation, because we're doing a full circle, so 360 degrees, a square is a regular figure. So to figure out the angle of rotation, you're going to take however many sides it has, so that's 4 sides, and you're going to do, 360 divided by however many sides there are, and there's 4. 360 divided by 4 is 90 degrees. So every single 90-degree turn will map a figure onto itself. Now it says, or square onto itself. Now it says select all, which means there's going to be more than one answer. Well, clearly, 90 degrees is the correct answer. Are there any other angles on there that 90 degrees can divide into? Yeah, that's 180 and 270. Okay, 180 degrees is 2 90-degree rotations. 270 degrees is 3 90-degree rotations. So those are also going to be answers. 45 is not, because 45 is half of 90, so it's not quite a full 90-degree turn. Okay, so go ahead and you can try that extra practice, or extra credit practice on campus.